8.6 is about distributing or multiplying with polynomials. And if we backtrack, we talk about some things that we did many moons ago, and you probably did this in junior high. We're distributing here. We would just simply pass out the 5 to the x and the 3 by multiplying, so we'd get 5x plus 15. And if there were multiple terms like this, 7 times 2x plus 4 minus 3y, then the 7 would get passed out to each of those. So this would give us 14x plus 28 minus 21y. All right. The other idea that we are going to use today in the lesson is what do we do when we multiply two monomials together that have different bases. So we want to remember when that happens, we multiply the two front numbers together, and then we're adding exponents. So this becomes a to the 4th, and the b stays the same, of course, because we're not multiplying by any other b's over there. So these are the two skills that we're using today, and I think that you'll find this lesson to be pretty simple. So let's go into the examples. Number 1, 5x times negative 3x squared plus 7x. And let's go ahead and write number 2 down. 2a squared times 5a squared minus 3a plus 4. We want to keep in mind our whole stair-step thing going on here. These are going to be multiplication problems. So we've got exponents, multiplication, addition, nothing. So distributing is a form of multiplying. So we're going to be at this step every time, which means we're going to be adding the exponents every single time here. So just be careful with that. So we're going to pass out just like we did here, but we're going to combine this idea with this idea to do this. So 5x times negative 3x squared, 5 times negative 3 would be negative 15, and then this becomes x cubed, because remember that's really x to the first power. Then we take that monomial and multiply it by this guy. So we get 5 times 7 is 35, and x times x is x squared. So we have a monomial, a single term, multiplied by a binomial here. This time we have a monomial times a trinomial. So we just pass them out individually. 2 times 5 is 10, a to the 4th. Add the exponents. Then pass the guy out here. 2 times negative 3 is negative 6, a to the 3rd. And pass this out here. 2a squared times 4 would be 8a squared. That's it. All right. I can give you more challenging ones, but that is really the base. So I'm going to write down a couple problems to have you try them. Number 3, 2m cubed times 5m to the 5th plus 3m cubed minus 2n squared plus 10. That's 3. And then 4, negative 2a times negative 3a plus 2 minus 4 times the quantity 2a squared minus 8a plus 5. All right, why don't you try those two? Just because they're longer, it doesn't mean that they're more challenging, especially number 3. So we're going to go ahead and distribute. Go ahead and push pause and see how you did on those. All right, so let's give it a shot. So this gives me 10m to the 8th plus 6m to the 3 plus 3 is 6 minus 4m to the 5th plus 20m to the 3rd. How'd you do? So we are multiplying the coefficients, adding the exponents. All right. Number 4, you're going to pass this guy out to these two, and the negative 4 out to these 3. So we're going to do 2 steps in this one. Negative 2a times negative 3a is positive 6a squared minus 4a. And then here, this is negative 8a squared. Negative 4 times negative 8 is going to be positive 32a. And negative 4 times 5 would be negative 20. So if you went that far and you got all of that, that's great. But how many of you looked at that and said, oh, I can combine like terms and simplify this even more? So what terms could you combine that are alike? We've got a 6a squared and a negative 8a squared. That's going to give us negative 2a squared. Now here's what's happening. We distributed, which was a multiplication, so we added the exponents. Now it's really an addition-subtraction problem, which tells us we do nothing to the exponents. We're moving down the stair step. So it was a squared minus a squared. We're going to do nothing to the exponent, so it's still an a squared. Negative 4a plus 32a will give us positive 28a, and then the negative 20 comes down. Okay? So that's distributing in a nutshell. You may have to combine like terms if the problem requires that. Now here we had m to the 8th, m to the 6th, m to the 5th, m to the 3rd. None of them are alike. And that's what happened in these first two as well. This one, we ended up having like terms, so you should combine them if you ever can combine them.